Hello, our esteemed viewers. You are welcome once again to our favorite mathematics YouTube channel, Mathematics by Abu Zainab. The channel is specially created for you and I to tackle mathematics and demystify the age-long phobia associated with this all-important subject, one topic at a time. Today we are continuing from our last video where we introduced the concept of surds. And I did explain then that surds are an example of irrational numbers that cannot be expressed as fractions, that is numerator over denominator. Without wasting much time, we delve right into today's lesson, which has to do with the additions and subtraction of surds. Of course, understanding today's topic is dependent upon having viewed the last video, which I'm going to urge you, if you are not, to please do. Thank you, and let's dive in. So with two examples, we are going to explain the concept of addition and subtraction of surds. To start with, we have 2 root 48 minus 5 root 12 plus 4 root 75 plus 6 root 32. The very first thing to do is to break these surds down to basics, each of them to basics. And from our last video, we understood that the basics simply mean break each number, the surd, into two values, factors of each of them being one perfect and the other non-perfect. So 48 is simply going to be 16 by 3. Because that's the best way you can have one perfect and the other non-perfect. The question might arise, why not say 12 times 4? Yes, 12 times 4. 4 is perfect. But from that 12, you can still break it down to a perfect and one non-perfect, which is 4 and 3. So that's like a longer route. Instead of saying 12 times 4, and now breaking the 12 into 4 and 3 again, why not go straight directly 16 by 3? Then minus 5. 12 is simply 4 by 3. Then plus 4. 75 is simply 25 by 3. And lastly, 32 is simply 16 by 2. So that's step 1, breaking each surd down into the basic form. From there, we can have 2 by root 16 is 4, then times root 3, minus 5, root 4 is 2, then root 3, plus 4, root 25 is 5, then root 3, and plus 6, root 16 is 4 by root 2. Then we can multiply the coefficients, the numbers at the front of the square root symbol. So you have 2 times 4, 8 root 3. Minus 5 times 2, 10 root 3, plus 4 times 5, 20 root 3, plus 6 times 4, 24 root 2. At this point, we have reduced to the simplest form. And we can see basically we are having those root 3's and then a single root 2. Now, here comes the concept of like and unlike terms, like we have in algebra. The like terms are the roots. So you have root 3, root 3, root 3. Those can be added and also subtracted together because they are similar. So we're going to say 8 root 3 minus 10 root 3. It's like saying 8x minus 10x, which gives us minus 2x. So that's going to give us minus 2 root 3. Then plus the 20 root 3 that is left behind, and plus 24 root 2. We still have like terms here. Minus 2 root 3 plus 2 root 3. They are like terms because of the root 3. So this is as good as saying 20 minus 2. It is simply 18 root 3. And plus 24 root 2. We can't go further than this because we can't add root 3 to root 2. The same way you cannot add x to y. And that is the answer. We can't go further than that. I believe it's quite simple and quite explanatory. If so, let's delve into example 2. So for example 2, you have the square root of 108 minus 3 by the square root of 20 minus 7 by the square root of 45 plus 2 square root of 125. Okay, we are going to follow a similar approach to example 1, whereby we break each number down into one perfect square and other imperfect, rather surd. So root 108 is simply root 36 times root 3, using the basic rule of surd. Minus 3. Root 20 is root 4 times root 5. Then 7 root 9 root 5 as well. Then lastly 2 root 25 times root 5 as well. Don't forget again, there are a myriad of factors you can get for each number, but you must stick to the ones that give us strictly one perfect and the other surd. As you can see, 108 is 36 by 3, 20 is 4 by 5, 45 is 9 by 5, not 15 by 3, and 125 is 25 by 5. Then we take the square root of each number we have here, 6 root 3 minus 3 times 2, root 5 minus 7 times 3, root 5 plus 2 times 5 root 5. We are simplifying the square root of the perfect squares and multiplying by the existing number. So here we have 6 root 3 minus 6 root 5 minus 21 root 5 plus 10 root 5. And here again we have like terms and unlike terms. So as you can see, in the basic forms, we have root 3, root 5, root 5, root 5. That clearly shows that root 3 is on its own, whereas these root 5s can be summed together. So we're having 6 root 3, then minus 6 root 5, minus 21 root 5. That is minus 27 root 5. Then plus the 10 root 5. That gives us 6 root 3, minus 27 root 5 plus 10, that is minus 17 root 5. And once again, we can't go further than that. That is the last step of the solution, which, as you can see again, is quite simple and very, very self-explanatory. I believe the example on addition and subtraction is quite succinct and explanatory enough for a good understanding of this concept. And we just will come to the end of today's lesson, which has to do with addition and subtraction of surds. So in summary, basically have to first express each surd as a basic form. How do we achieve that? We break the number into a product of one perfect square and the other is surd, which cannot be broken further. After which, we do the same for all the numbers under the square root sign, all the surds. Then, simplifying further, we extract and collect like terms. And I did say that like terms are based on the square root. So similar terms under the square root are the likes. You can only add like terms and subtract like terms, just as we have in algebra. You can't add root 3 to root 2. It's not possible. So after adding or subtracting the like terms, as the case might be, then you have your final answer. And that has been the lesson for today, which I hope you enjoyed. Please, don't forget to like, share, subscribe, and most importantly, tune on your bell so that you'll be the first to know when our next video drops. Thank you, and stay blessed.